So I'm going to explain question 4, part A, from the 2012 AP exam. Part A asks you to write a method to count the white pixels and then return the amount of white pixels within a 2D array. So for example, in this problem, there are 5, it would return 5 since there's 5 white pixels, and the value of a white pixel is 255. So I wrote the solution, but it's similar to the Litvin solution. It's almost exactly the same, but it's up to our class coding standards. Basically what it does is it searches through the 2D array like in any other nested for loop that we've been learning. So first it goes in row major order. So first it goes by row, then by column, and it searches each value, and if that value, as you can see, is equal to white, and white in this case is 255 since that's, like I said, the value of a white pixel. If the value is white, then the count goes up. The count keeps track of the number of white pixels within the 2D array, and then after searching through each value in the 2D array, it returns the count. So you can use that in, for example, a system out print, as I will do here in 1 second. Let me comment out the stuff. So this should return the number 5 for this array. Yeah, so it returns the number 5, so it works. As you can see here, it meets these requirements. It returns the total number of white pixels within the image accurately, and it meets the post condition since it doesn't change the image. Unlike part A, part B asks you to modify an image. You would do this by changing the values, obviously, of the 2D array. Like the previous question, the 2D array goes in row major order, so you have to go from left to right and then from column to column. Well, you go from column to column by going from left to right. The pixel values change. They're decreased by the value of the position that's 2 rows below it and 2 columns to the right. So for example, right here, 221 is in 0, 0, and the number 0 is subtracted from it. So after the call to process image, it would once again print the same thing. Well, it wouldn't print the same thing, but it would store the same value as previously since it wouldn't change. However, if you subtract it by a number that's greater than it, like in 10 right here, it's 84, and 255 is subtracted by that. So that just becomes black, which has the value of 0. So this changes, 84 would change to 0, and so on. So here I have the Litvin's second solution to this problem. They had 2, but the other one uses math.max, which isn't tested on the AP exam, so I decided to just add the second one. Like the previous question, it goes through the 2D array. However, in this case, since it has to do length and then minus 2, since it is subtracting from the number that's 2 rows down and 2 columns to the right. So for example, like this, it's 178, 78 is subtracted from that, but 84 obviously can't be changed. So anything on this, the last 2 columns won't change, obviously. However, the other ones are still affected. So it does the same thing, the same basic thing for the columns. So yeah, and same thing for rows. So if the rows are on the bottom, obviously these aren't going to change because they can't go down 2 rows from that position since they're the second to last and last row, respectively. It creates an integer known as p. What p is used for is it's the value within the array minus the value. It's the value minus the value that's 2 rows down and 2 columns to the right. So r plus 2, c plus 2, obviously. So for example, 255 is 0 subtracted from that. So p in that case would be 0, and p isn't less than black. P is equal to black, so p isn't less than black. So this doesn't run, and pixel values just stays 255. Since this would have been 255 and this would have been 0, 255 minus 0, obviously, 255, so that stays 255. What this does is, since it's an image, it prevents a negative number from occurring, basically. So what it does is, since black is 0, as you can see here, it's a final integer. Since black is 0, if it's less than black, it just becomes black, which is 0, obviously. So this processes the image in row major order and decreases the value of each pixel by the position that's 2 rows down and 2 columns to the right, if it exists, which basically the -2 is what makes sure that it exists. So yeah, resulting values would be less than, so as I said, resulting values, if they're negative, they just become 0, in this case black. Pixels for which there's no pixel are unchanged. So like I said, nothing is subtracted if there's nothing 2 rows down and 2 columns to the right from that value specifically. So that's how you would answer 2012's AP Computer Science exam, question 4, part A and B. Thank you.